Hello? Oh no. Hello. All right, let's get started today. It's actually, although it shows that there are 70 slides, actually there are only really only 35 or so in this chapter. The next chapter is also somehow included in this PowerPoint presentation, but we are not going to be covering that this week. We are only going to be doing the chapter 10 today. Chapter 10 deals with capital budgeting, which means you're going to be looking at these four methods. In addition to these four, there are a couple under this, like for example, under IRR, there are two kinds. One is regular IRR. The other is what is known as modified IRR. And under payback period, there is simple payback period and there is discounted payback period. We are going to be dealing with both of them. So let us start with the first one. You already know what this is, net present value. The present value of a stream of future cash flows from the project minus the project's net investment. Now, what do you mean by this? Basically, you take the present value of all cash inflows and deduct the net investment. You can say only inflows. No, not necessarily. If there are outflows after time zero, you'll include them in the first part. Only thing is they'll have a negative sign. That's fine, because you're adding it all up. Take out the net investment, and that's how you get. And the discount rate you use here is the cost of capital. K is cost of capital. It's the simplest and by far the best method for calculating the required, accepting or rejecting a project. Now, what do you mean by that? Like, for example, take the case of this. This is NPV. You already know how to do it on the on the calculator. But I'm going to show you all the same. If you look at it, if you look at the NPV here, now project A, net cash flow after taxes, 12,500. You know, you are looking at two projects. The net investment is the same for both of them, project A and project B. A is 50,000. B is 50,000, so it's the same net investment. The cash flows are, A is an annuity, you're getting 12,500 a year for 6 years. B, you're getting 5,000, 10,000, 15, 25, 15, again 25 and 30. So if you are calculating the NPV, how do you do it? Well, let me show you all how to do that. Where is it? Uh-oh. Let's see. Now let me see this. Will it read it? Ah, there you go. It is now reading it. Now, cash flows, second clear work. You can all see my calculator, right? You can all see it? Okay. Well, I'm going to work on it. 50,000 is negative at time 0. Enter, down arrow, 12,500. Enter, and this has come for 6 times, right? So 6, enter, NPV. Now, does anyone remember what the interest rate was? I don't think you do remember, right? Okay, let me close this. We have to go back there. What was it? They're using 14%. So let us go back and use 14% there. If you use back 14%, let me go back there, use the calculator. 14, I is 14. Enter, down arrow, compute. It's 1391. Now, we are done with that one, that problem, NPV. So, let me go back again to the mainframe. It's taking too long. Okay. All right, there you go. If you look at this, now you look at equation 10.3, you already know how to calculate NPV for an uneven cash flow. I'm not going to bother showing you that again. But this is exactly like that. Only thing is, only in case of 15,000 do you use F4 to all one cash flows. It's 7,735. Whereas in case of NPV we got was minus 1391 there. Minus 1391 was the NPV we calculated there. So you would be rejecting project A, accepting project B. So that's NPV. You just calculate the present value of cash inflows and deduct the initial outlay. Any questions on it? You already know this, right? How to decide if you should accept or reject a project. Okay, now accept if NPV is greater than 0 and reject greater than or equal to 0. Why do they say 0, not 1? That's simple, because sometimes the project, you accept a project even though it's not going to make you a profit. What it will do is it will add other benefits, like it will get your name known to customers, things like that. Mutually exclusive projects, you accept the project with the largest NPV. What about the sources of positive NPV projects? When project and factor markets are not perfectly competitive, it is possible for a firm to earn above normal profits that result in positive NPV projects. Example, buyer preferences for established brand names, ownership or control of favored distribution systems, patent control, exclusive ownership of superior natural, all these actually have examples. Like for example, if you take the case of this, De Beers is a good example of this last one. This Pfizer was a very good advertisement until recently when they had control of some special drugs that are now become available generic. Ownership and control of favored distribution systems. I would say Walmart is a very good example of this. And buyer preferences for established name brands. In this, you can name anything. Like for example, Toyota and Honda are really good examples of this. All these have examples of where you get those. Now, what are the advantages? NPV's greatest advantage is theoretically it is the best criteria there is, and it makes a realistic assumption that cash flows are reinvested at cost of capital. It considers the time value of money. All these are important. What are the weaknesses? NPV is not easily understood. You say NPV is 250. A lot of non-finance people would not know what you're talking about. And it does not consider the value of real options. That means abandonment option and other things. But despite everything, NPV is considered to be the best possible method by most people. Now, profitability index is nothing but NPV expressed as a function. What they do here is you take the present value of cash inflows and divide it by net investment. So like for example, you take the present value of cash inflows. Let us, what was the problem here again? Let me go back to the problem. Okay, this one. The present value of cash inflows is 57,735. That divided by 50,000 gives you the profitability index for that project. So if you divide it, you get probably around 1.125, something like that. 25. Let me do that here. I'm gonna do it off screen. 57,735 divided by 50,000, which is the initial outlay, gives you 1.1547. So that is the profitable. That means for every dollar you're investing, you're getting 1.15 in return. So that is profitability index. What about the first project? You're only getting 48,613, which means you're getting less than 50,000. So 48,613 divided by 50,000. You don't get much, you get 0.97. So the first one, if it is less than profitability index is less than 1, you reject it. So that's what it is. I mean, here you take the present value of cash inflows, which is in the numerator, and divide it by the net investment. See? Any questions on this either? Well, how do you decide? You accept if the profitability index is greater than 1 or equal to 1, and you reject if it is less than 1. In mutually exclusive projects, you accept the project with the largest PI. Now we come to probably the one most controversial method. And what is this? This is the internal rate of return. Internal rate of return is that rate of return at which the present value of cash inflows equals to net investment. That means, remember, if you are all looking at this formula, do you see cost of capital anywhere there? Are they even including cost of capital anywhere in the calculation? Do you see it there? You don't. You know why? Because it's the rate of return at which present value of cash inflows exactly equals net outflow. That means you're trying to find a rate of return where at which the present value of all future cash flows from the project exactly equals net investment today. It is the discount rate that equates NPV equals 0. So how do we do it? Now if you look at it, the decision rule is accept if the IRR is greater than cost of capital, mutually exclusive projects. Like for example, how do you do IRR on your calculator? Let me show you. Okay. let me show you that. Are you all seeing my calculator right now? You are? All right. Now, we entered all the cash flows. You all remember? Look at the cash flows, 50,000, 12,500 per year for 6 years. Okay, I'll do project 1. All you need to do is, once you do cash flows, then press IRR and say compute. It will give you the IRR. That's all. Isn't it simple to do it on a calculator? Instead of pressing NPV, you just press IRR and say compute. No, we did it for all the cash flows together. Like for example, for project B, for part B, if I remember right, let me clear the calculator first. Let me clear out the calculator. Now it is empty. Do you all see? Let me do project B and show you. Cash flow at time 0, I cleared the calc registers. 50,000 was the initial outlay. Enter, down arrow. I think the first year it was 5,000 if I'm right. Am I right? First year was 5,000. Enter, down arrow. And 5,000 occurred only once, if I remember right. Does anyone have the cash flows with them? I think, let me look at the textbook here for a second. I'm pretty sure they have it in the textbook. Yeah, it's in page 361. Okay, 5,000 is the cash flow in year 1. Okay, one time, that is. Then 10,000 in year 2. Enter, down arrow, twice. Then 15,000. Now, I want all of you to notice that 15,000 occurs twice. So, how do you enter 15,000? Do you enter it twice or do you just say 2 here? What do you do? Remember? What do you do here? Yeah, just enter 2 here. Enter, down arrow. Then you have 25,000 and 30,000. 25,000. Enter, down arrow. And 30,000. We have all the cash flows in now. Enter. Okay, now I press IRR and say compute. Huh. What did I do? It is correct. Why did it stop working today? Ah, now I know why it is. What is the mistake I made? Can anyone tell me? What is the mistake I made, ladies and gentlemen? Can anyone tell me? Exactly. In my hurry to do this on the calculator, I forgot to include a negative sign there. This should be negative. See? Now it will work fine. You all see what I mean? You could be doing this all your life. You can still make a mistake if you're overconfident, as your teacher has just shown you. There is no way it can calculate an IRR because the first cash outflow was positive. It has to be negative. So it's easy. IRR calculation is easy as far as this is concerned. So let me go back to my lecture. Now accept if IRR is greater than cost of capital, and there will be problems with IRR, especially normally this is how IRR works. Okay, this is your cost of capital, 14%. Okay, you can see IRR is below 14 when it comes to project A and above 14 when it comes to project B, which is 18.2. So normally for conventional projects, NPV and IRR both give you the same result. But for unconventional projects, things could be very different, because what will happen is sometimes NPV is better for one and IRR is better for the other. When will this happen? Okay, I'll come to that in a few minutes. The advantages of IRR is it considers time value of money and the interpretation is easier than NPV. And the disadvantages are non-normal cash flow pattern can result in multiple IRRs. There is the assumption that cash flows are reinvested at IRRs sometimes unrealistic and does not consider the value of real options. Now, how do NPV and IRR differ in how each handles the reinvestment of cash flows? Let's take a look at that. The reinvestment rate assumption assumes cash flows are reinvested at cost of capital. IRR assumes cash flows are reinvested at IRR. If you looked at the formula for IRR, when we looked at it here, no, that is not it. IRR, where is it? This is the one? Yeah, that's the one. If you looked at it, cash flows are being reinvested at internal rate of return, which is not true. It is not true because you assume cash flows are actually reinvested at cost of capital. So that's a major drawback of IRR. And because of that, IRR has problems with it. And there is something in your textbook that I want all of you to read as homework. Where is it? Well, looks like they have removed it in this, well, they added MSCRS, so. Okay, it's in page 363, 362 and 363. It's about a cash flow set which actually gives you an IRR of 2 to 3 different IRRs. It's correct. I want all of you to read that part to know what is wrong with IRR. Okay? Yeah, I know. Today I increased the font size several times, Carla, but it still is not working fully well, but it's a lot better than, for me, it's a lot better than it used to be under, what do you say, Internet Explorer. Next week I'll try Google Chrome and see if it is better there. Apparently this problem has come with the new Java. They force us all to install new Java, the Java people, and this has come because of that. So there is the tech support people I talked to said they can't do much about it. I'm trying to find a way around it because normally there is a solution to the problem. I'm trying to find a way around it. I'll try to do it as soon as I can, okay? Okay, there is an arrow at the right end of the chat box. If you increase the font size, it might work. It is working for me. If you right click on it and increase font size, it works. I'm doing that right now. Okay? All right, now there is another thing I wanted to share with all of you. Because of these criticisms of IRR, let me go back to the previous page. Because of these criticisms of IRR, someone came up with the idea of a modified internal rate of return, MIRR. MIRR is slightly different from IRR in that what it does is, you take, like for example, let me take a blank page. No, not that a blank page. No, let me go here. Let me write new page. Okay, it works like this. MIRR works like this. Let us say you have this 50. I'm talking about thousands here. 5 in the first year, 10 in the second, 15 in the third, 15 in the fourth, 25 in the fifth, and 30 in the sixth. What MIRR suggests is you take the future value of all these, add them up, and call this terminal value. Okay, you take future value of 5,000 in years. This is what, let me write this down. 1, why is it doing that? 1, 2, 3, 4, 5, 6. According to MIRR, if you take the future value of this 5,000 for 5 years at 14%, which is the cost of capital, future value of this 10,000 for the same number of years for 4 years at 14%, and 15 for 3 years, 15 for 2 years, and 25 for 1 year and 30. And add them all up, you get a value known as terminal value in year 6. Find the rate at which 50,000 today equals the terminal value in year 6. That is called MIRR. Fortunately, you all don't have to go through all that, and you can actually do it the way I show you on the calculator. Are you all ready to see it on the calculator, how to calculate MIRR? All right, let me show you. First of all, calculate IRR. Okay? Step 1, calculate IRR. Next step, this is what you do. Press the down arrow. It will ask you for RI. You all want to know what RI means? RI means return on investment. That is where it's asking for the cost of capital. It wants to calculate the future value of those cash flows. So you tell it 14 because that's the cost of capital. Press enter. And then press the down arrow. It will give you MIRR. It is called MOD. MOD is 16.76. Do you all see that? This is the quickest and the easiest way to calculate MIRR. Is everyone with me? You understand? It's very simple. Calculate IRR, push down the down arrow. Like for example, once you get IRR, press the down arrow. It will ask you, what is your return on investment? When you press down arrow, it knows you're going to ask it for modified. So you say 14. And then you press the down arrow again, it will tell you modified is 16.76. It's simple. Now we come to the most interesting of all the methods. It's called payback. Payback is by far the easiest and the simplest methods of capital budgeting. Now what do we do here? It's actually pretty simple. You take, like for example, this is an annuity. What you do here is you take the initial investment and divide it by annual cash flows. You get 4 years. Okay. And the second one, payback means 4 years. That means here you see one thing in payback. They are ignoring, I'm repeating again, they're ignoring time value of money, which I told you all a long time ago is practically a sacrilege, right? Isn't that what I tell you? It's a sacrilege. You should not do it. You have to calculate. You cannot add cash flows from one year to another year. I told you that, didn't I? Well, I'm telling you to unlearn it just for payback period, because in payback period, simple payback period, you can add cash flows of one year to another year like this, like what they're doing here. At the end of second year, you earn 25,000. At the end of third year, 7,500. At the end of fourth year, 50,000, which means 4 years is what it takes for the money to be paid back. Unfortunately, not everything is an annuity. So you'll also have some other things, like for example, what's a discounted payback? Now, discounted payback is where you take the present value of the cash inflows, discount them back to present using 10,000, the 14% as the discount rate, and then calculate the cumulative cash flow. Like, how do you mean by that? I'll explain. In the first year, you're getting 12,500. Am I right? The present value of that cash flow at the cost of capital is 10,962. So you write cumulative cash inflow is 10,962. In the second year, you're getting 12,500 again. The present value of that at 14% is 9,612. Cumulative cash flow would be 10,962. This plus this equals this. 10,962 plus 9,612 equals 2,575. Do you all see? It is cumulative. That means how much are you adding? Because you're taking the present value before you're adding it. Okay? Then you add that to this and you get this. And you add this to this, you get this. And you keep doing it until the end. But normally, if it pays back something, but in this case it does not, because remember, this had a negative NPV. That means it never gets to 50,000. But if there are times when it gets to 50,000, like for example this one. In this case, this is a mixed cash flow. Here what you do is, you simply take the undiscounted cash flows, 5,000 in the first year. This is simple payback. This is discounted payback. In simple payback, you add the cash flows 5, 10, that is 15,000. 15 and 15 is 30,000. 30 and 15 is 45,000. 45 and 25 is 70,000. Stop. Somewhere between 45 and 70 payback occurred. That means you got all your money back. How do you know that? Because 70 is greater than 50. 45 is less than 50. So payback is number of years before recovery of net investment, which is 4 years. It is greater than 4 years, less than 5 years. So put 4 plus how much you still need to recover at the end of year 4. 50 minus 45 is 5,000. 5,000 is the numerator. And the denominator is how much you are actually getting in the year 5, 25,000. So 4 plus 5 by 25 is 4.2 years is simple payback. Any questions on that? Can I explain again how I got the cash inflow amount? Cash inflow amount, you mean these, Gauri? These cash flows? You mean these cash flows? Oh, sure. These ones? You want to know these ones? Remember, we started the chapter with two particular problems. I'm using the same problems to explain it. I'm using the same problems to explain it. Like, for example, if you look at your textbook, these two problems are given in page 357 in table 10.2. You see it? Do you see it? I can't see her answer. If I increase the font size, everything is disappearing. I got the cash flows from there. Let me increase the font size of that again. Okay. I can't see. Are you there? Can you all hear me? The rest of you? Do you know where I got these problems? It's from the textbook. It's the examples from the textbook. And it is also given in one of the first slides. I'm using the same problems. One's an annuity, one's a mixed cash flow. Are you all okay? All right. That's where I got the cash flows. This is the annuity problem, where you don't get a payback because it doesn't pay back 50,000 in discounted value. The next one is project, the second project, project B, where you start adding up and you calculate the payback. Okay? Any questions on that? Gauri, did you get it? Miguel, thanks. Okay. Now, discounted cash flow, what you do again, it's the same thing. You calculate the present value of each of these, and then you accumulate the cash inflow. You see here? Adding this to this, because this is discounted is a lot better, gives you this, and so on. So at the end of 5 years, you have 44,055, but somewhere between year 4 and 5 and 6, you get the, year 5 and 6, you get the discounted payback. So you take unrecovered initial investment at start of year divided by discounted cash flow inflow during year. So 50 minus 44,055 by 13,680 is 5.43 years. That's how the answer is. Okay? Now, I want all of you to do, let me ask you all this. Take the case of this project, simple payback. There are a lot of criticisms of simple payback. Okay, we'll come to that in a minute. You all want to know how to do these on a calculator? I'm sure you want to know. Okay, let me go there again. Okay, are you all ready? Okay, let me show you. Now remember, let me show you the second one. You can figure out the first one. This was the second one, right? 50,000 initially. Cash inflows of 5, 10, 2 15,000s, 25, and 30. Am I right? You all remember? We entered it for the IRR. Okay. Now assume you are doing NPV. If you are doing NPV, what do? You press NPV and it will ask you for the cost of capital. You tell it it's 14%. Enter, you down arrow, and then you press compute. It will give you the NPV. Am I right? Until here, you can't see it? I don't know why it's paused my hosting. Okay. Can you see? Okay, was I on the calculator all this time? Now, did you all see the PowerPoint presentation when I was talking earlier? Okay. Now, let me try to go to the calculator and show you. Okay? Let me try to go to the calculator and show you. Looks like there is some problem today. I don't know what. Let me go to the calculator and show you. Can you see my calculator now? Okay. All right. Let me go back here. If I look at the cash flows that we entered earlier for problem B, I'm going to show you problem B. Okay. Look at this. Cash flow at time 0 is 50,000. Negative. Down arrow 5,000, 10,000, 15,000, and 15,000, if you all remember, came twice. That's the reason we use that. At 25, then 30, right? You all remember until there, don't you? Now comes the interesting part. You press NPV, you press 14, enter, down arrow, and you press compute, you give the NPV. Okay, we all know this. Now, once you get the NPV, that's when the fun begins. Press the down arrow again. It asks for NFV. Do you want to know NFV? No. So press the down arrow again. It says PB. PB stands for payback. Let me just show you all something. I press compute. It is given me payback of 4.2 years. Was that the payback in our problem? Was that the payback in our problem? Easy, right? Isn't it easy here? This is one chapter you can do completely on the calculator. Now, you press the down arrow again, DPB, that is discounted payback. Again you press compute, 5.43. Ain't it easy? You all know at the beginning of the semester, I insisted you all get the professional version of the calculator. Do you remember? The reason is MIRR is calculated only by the professional version, not by the regular version. That's the reason I insisted. Do you see how easy it is to do it here? Get NPV. Okay. Once you get to NPV, press the down arrow, NFV. You don't want NFV. Payback, compute. Then discounted payback, compute. That's it. You get every answer. Okay? Yeah, I know. Okay, what are the advantages and disadvantages of payback? It is simple. It provides a measure of liquidity. It's a measure of risk. Like for example, I don't know, some of you, I know that most of you don't live in commerce, so I'm sure some of you work. Is there anyone in the class who flies first class? Okay. I flew first class just once. Okay, there was this credit rating company out of San Francisco, and they wanted me to come out to interview for a credit rating job a long time ago, and they flew me first class from Fayetteville, Arkansas to San Francisco. And it was fun. When it lasted, it was fun. They give you champagne, they make omelets for you, and it was a really cool flight. And this was when I was a student. This was 1997. So I sit down in the first class, relax. I mean, the seats were 10 times more comfortable than um, the class I fly in normally. And guess what happened? A guy came, sits next to me, and he says, "What are you doing, young man?" By the way, much as it is hard for all of you to believe, someone actually addressed me as young man in those days. I said, I told him, I'm getting my PhD. I'm pretty close to finishing. I'm going there to interview with this company known as, I can't even remember the name of the credit rating company. It's not one of the top line ones. So he said, I told him I'm going there. He said, oh, you are a finance, so you're going to be a finance professor afterwards? I said, yeah, I hope so someday. I want to start as assistant professor, but I hope to be a full professor someday, within 10 years or so. He said, let me ask you this then. Do you still teach your students that payback is a bad method because it adds up cash flows from one year to other? I said, sure, I teach that because it is right. It is horrible. He said, no, you're wrong. It is the best method of capital budgeting there is. And I thought, what's he talking about? The textbooks tell me it's wrong. I asked him why. And he told me the reason. He says, you calculate cash flows for 10 years, 8 years. How many projects do return cash flows for that many years? Like, for example, today if you have a new project, okay, new product, an electronic product, how long do you think it will sell? 2 years? 3 at the most, right? It won't sell beyond that. So he said, you try to get your investment out, and anything above is profit, because someone might come up with a better model by tomorrow morning. By the time your product hits the market, it could be outdated. He said, it's not like the olden days, and this was 1997. He said, it's not like the olden days. You don't have time. So that's one reason payback period is still very popular, because the way companies look at it is, I'm coming up with the iWatch, okay? Someone else is working on an improved version of iWatch. So obviously, that's going to be better than mine. So what I try to do is, I try to get my investment out, and anything above is profit. That is one reason. The second is Me Too products. I need a volunteer in the class. Someone to volunteer, I need to state an example. Anyone volunteering? Okay, Miguel. Okay, Miguel and Kija. Miguel and Kija. Wait a minute, I'm typing. Okay, they both have a company that is named Miguel and Kija Pharmaceutical Incorporated. So Miguel and Kija realized one thing, okay? Most human beings have a nose, and most human beings get a cold sometime or the other that they pass off as allergies. Okay, so they think everyone's spending money on cancer research, trying to get a cure for Alzheimer's. Let us try to cure the common cold. So they invest about $2 billion, and they come up with a product known as MK Miguel Kija Cold Cure. Okay, they come up with a product. Now, let us say they have a competitor. This guy goes by this name. Okay, he's how do I put it? Morally maneuverable. Okay, morally maneuverable a little bit. He's not worried about things like patent laws, keeping up, allowing others to have their own copyrights and things like that. He waits until the product hits the market. So he sees MKCC, it's a cold product, and it is selling at $10 a bottle because they have to recover their investment. So SN enters the market, buys a couple of bottles of MKCC, and as a chemist, he can figure out what's in there. And since he's morally maneuverable and has a few lawyers who will tell him how to get around the patent laws in several countries, he comes out with his own version of MKCC, known as SNCC. Okay, SN Cold Cure. And since he didn't have to pay a lot on research, he comes to sell it at $2 a bottle. This kind of thing is called a Me Too product, right? It is a Me Too product. Guess who'll sell more? You all want to guess who'll sell more? SN or MKCC? MKCC will sell, this SN guy will sell more, I can assure you of that. You know why? Because he's selling it cheap. At least he'll eat into the profits of MKCC. That is called reality in the market. Yeah. Unless, of course, people go for generic brands. That's the reason you all need to buy generic brands, because when you are buying generic brands, you're paying for research, which is how human race will advance and we'll all see the next generation of products. Payback period takes advantage of that. They know that human beings are weak and there are patent laws which can be broken, which can be turned around, and because of that, what they try to do is they try to make it easier. So payback gives you that. So these are the advantages of payback and disadvantages. Now, that's what that guy told me, and he's right. Well, you can read these. Let me talk a little about. Many firms do not have unlimited funds available for investment. Actually, there is one slide I missed. What should a firm do if it does not have enough money to invest in all its positive NPV projects? You can do what Warren Buffett does. Ask other companies, do you have any projects that are available? Many firms do not have unlimited funds available for investment, so there is a constraint on the amount of funds allocated to capital investments. When there is a capital budgeting constraint, an approach employing a profitability index can be used. So you can rank them like this and see which one you accept. You know, you accept the ones with the highest PI. Well, capital rationing means you search for a combination of projects that will increase the cumulative NPV. What about after you're done with projects? You compare actual cash flows to projected cash flows, you find systematic biases or errors in uncertain projected cash flows, and decide whether to abandon or continue projects that have done poorly. Now you also have real options in capital budgeting. What do you mean by real options? This is something you need to read from the textbook. It's easy. Basically, you look at investment timing. Timing is everything. Delaying investment in a project may allow firm to evaluate additional information. Sometimes a firm could be ahead of its time. If it introduces a product ahead of its time, it could be a failure. Or the abandonment option. Sometimes you don't want to continue your mistake. You want to stop and move on. You look at shutdown options. You look at growth options. You can look at input flexibility, output flexibility, and expansion options, things like that. What are real options? And those are all real options. And how are they being applied? Some firms use real options concepts to frame a way of thinking about decision analysis problems involving capital investments. So I want you all to work just this one problem. Please go ahead and try this one problem. Initial investment of -800, cash flows of 100, 200, 300, 400, 500 in the first 5 years. Given the cost of capital of 10%, I want you to tell me what payback is, what discounted payback is, NPV, IRR, MIRR, and profitability indexes. Please take a crack at them. Go ahead, do it. Okay, looks like you all got some answers. NPV is 265.25. Let me go to my calculator and we can do this, okay? Okay, first cash flows, second clear. 800 negative, enter. I think that was my initial outlay, am I right? Okay, down arrow, 100, enter, down arrow twice, 200, enter, down arrow twice, 300, enter, down arrow twice, 400, enter, down arrow twice, 500, enter. Now NPV 10 is the interest rate, enter, down arrow. Yep, 265.25. Okay, and profitability index will be NPV plus initial outlay, which is 1065.25 divided by 800, which should give you that, right? Okay, now that we got NPV, let me do payback. Compute. 3.5, is that what you all got for payback, right? Okay, then what was discounted payback? Compute. 4.14. Do you all get that? 4.14. Okay. Now we need to do IRR. Compute. 19.53. You all get it? Well, down arrow, return on investment is again 10. Enter. And modified is 16.48. Did you get that too? Okay. Let me go and check our answers. Payback 2.35. Discounted payback 4.14. NPV and profitability index. Profitability index is simple. You need to take present value of cash inflows, which is 1065.25 divided by 800. You add NPV to initial outlay, you'll get the same. IRR and MIRR, we got those right. Okay? Did everyone get these answers? All right, ladies and gentlemen, I'm done for today. The rest of the PowerPoints actually belong to the next chapter, which we'll do next week. And I won't be in town the rest of this week, so please don't email me unless it's important until Sunday, okay? I won't be back until Sunday. I will have very limited access to email later this week, okay? Have a nice week and please log off.